Good morning or good afternoon to some. Welcome to our webinar today. Thanks again for joining us. Our webinar today will be 30 minutes long with time at the end for question and answer. During the webinar, you can send your questions through the chat window, and we will answer your questions during the Q&A portion at the end of the webinar. We will be issuing PDH certificates for those attending the live session that have elected to receive them, and we'll be sending those out within the next 24 hours. We do encourage you to visit our website, bartlettwest.com, and click on the Webinars tab to see upcoming webinars and to register. All of our webinars will be available on demand after the live session, so you can check those out there at any time. Today, we're going to hear from Mike Lorenzo, who leads the company's collection systems department in the planning and design for projects related to combined sewers, storm sewers, and sanitary sewers. He is also a leader at Bartlett & West's Asset Management Service Department. The department has developed web-based products to link collection system and other asset information to geographic information systems, as well as our custom computerized maintenance management system. Mike has 40 years of experience in facility planning and design of collection systems for municipalities of all sizes, municipal wastewater treatment facilities, and peak wet weather flow facilities. Today he'll be discussing asset management. It's the journey, not the destination. And without further ado, I'll turn it over to Mike.
Good morning. Thank you, everybody. Thank you, Rebecca, and thanks to everybody for attending. I hope you'll like this presentation. It's something I find very interesting and enjoy the process, and happy to share it with everybody today. So let's get started. So what is asset management? I know when I think back, it's perhaps a more sophisticated version of repair and replace like we all did a long time ago with operation and maintenance. But when I look at United States Environmental Protection Agency's meaning, they call it a process for maintaining a desired level of service at the best appropriate cost. And I think you'll find a lot of different meanings, different services, different organizations define it differently. And, for us at Bartlett & West, we think about it as we have it at the bottom there, doing the right work for the right reason at the right time, right tools, right people, and for the right cost. And this leads to all kinds of benefits, and the largest benefits, that we see is that it improves maintenance for facilities and organizations to move them into a more proactive mode and avoid emergencies and mitigate risks. And that'll be a big theme for this, mitigating risks and prioritizing and getting in position to plan long-term improvements. I think also one of the keys that we'll get to talk about is the idea of rigorous and repeatable processes and making defensible decisions. And, a way of saying it is for an organization to tell their story. We always have to go in front of councils and city groups, elected officials, and asset management, I feel, is a tool that helps us tell that story. So one of the things we talk about is what can be managed, and it could be a whole variety of utilities and facilities and different types of assets. Now my concentration is in wastewater treatment and collection and stormwater systems. The presentation is kind of centric in that sense, but anything we're talking about can be applied to other areas, buildings, parks, roads, and sidewalks. The principles are applicable, but what you'll see is kind of focused on wastewater today, although we do have done other projects, and we could discuss those as case studies. So one of the things when we look at is that asset management is really, it's really a continuum of performance. And you'll see if you read the literature, there's various thinking about different levels. We look at it this way, and it's generally about what you'll see wherever you refer to. At level one is a very reactive state, it's fix when broken. Level two, plan, schedule maintenance is being performed. And as you proceed up, it gets more and more sophisticated, such as when you reach level five, there's predictive, proactive, and then there's also integration among the different aspects of an organization's work so that the engineering, procurement, finance, all of these arms are aligned and allow for a coordinated approach. And, that's probably the highest level where you could start looking at perhaps revising designs, revising construction methods to start developing inherent reliability. So what I would ask on this slide, just as a quick poll question, if you wouldn't mind participating and indicating what level your facility is at in terms of asset management, level 1 through 5. So give a couple of minutes. So as you're filling it out, I think about my car. It's always, how I relate to a lot of this. I like to think I'm a better than level 1. I am level 2, but I don't think I'm too predictive with what'll happen. Okay, results are coming in. Okay, interesting. I see there are no responders at level 1, so that's very good. See a lot of level 2 and level 3, 35% level 2, 45% level 3, and I think that's very good. A lot of our facilities are at that level. Um, a lot less at level 4 and level 5. Those are very advanced and sophisticated levels. So we're seeing 10% at level 4, 10% at level 5. I'm sure it'd be interesting to hear from those people later. So let's keep going. So the question becomes, when should an organization or utilities begin this process? And it's a very simple answer, in my opinion, now, right away. So we all know that, that old saying, journey of 1,000 miles starts with the first step. But I think that's a little bit of a misnomer, kind of not quite correct. You know, when we start our destination, we need to know where we want to go. Have to think about the route, get the car ready, get the maps ready, or GPS, and then we get the trip started. So there's a little more to it. We don't want to wander aimlessly. At the same time, we want to get the trip started, but the key is to be flexible so that you're making mid-course adjustments and improving as you go. And that's really the whole core of this. I'd just like to just kind of side trip here for a moment. As I was talking about, there's different types of facilities and organizations this can be done for, and these are examples very quickly of projects that Bartlett and West has performed. We've worked for a Department of Transportation, and this was cataloging and compiling assets across a long section of interstate. It was essentially data compilation. The condition had already been decided, but this was to understand where where the signs were located. This was all signage out on 922 miles of highway. So this was all done with mobile LiDAR to identify and catalog the signs. Another project was at a large university in the Midwest, and we converted existing GIS files to Esri GIS, developed mobile apps for data collection, and worked with the staff in data management. Again, this was one of the first steps we'll talk about is learning what the assets are and where they are. And one of the interesting parts is they included cataloging trees on the campus, and perhaps the next step will be regularizing their trimming and maintenance of the trees. Another interesting project was work we have done for Tribal Nation North Dakota. This was assessing the conditions of water hydrants across the reservation, again using Esri GIS with a digital dashboard and locating condition and asset information readily available. Now, the project that we're going to focus on today is one of our very best clients in the Midwest. We did a condition assessment and evaluation at two of their wastewater treatment plants, and we looked at about 1,000 pieces of equipment. As part of that, we developed a mobile app, and we developed approaches to put data into a cloud location storage where it went through a computerized algorithm to develop scores and use that then to develop recommendations. And we'll get into that in more detail. So a lot of references when you look at asset management, these are the five critical questions. This is very much in line with how EPA, US EPA views this. Current states of the assets, what are the sustainable levels of service, which assets are critical, what are the minimum lifetime costs, and what are the best long-term funding strategies. You know, each of these could be its own day of presentation, and what we'd like to do today is dive a little more deeply into questions 1 and 3. We hope we could do this for the future, perhaps look ahead and have more deep discussions on the other questions. But for today, we'll be looking at questions 1 and 3. So question 1 subdivides, and it's straightforward. What do I own? Where is it? What is its condition? And how much remaining useful life there is. And one of the things I think about this is there's a lot of common sense aspect here. But when we think about it, the first question that has to be answered is what is an asset and what does the owner really want to start digging into? When I think about a wastewater treatment plant, there's a lot of different aspects. There's the site and civil features, the roads, the areas that have to be mowed, fencing, things like that. You have equipment, pumps, there's controls, there's electrical, heating and ventilation. So there's a whole variety of things to look at. And the question is, what is going to be an asset? And then the other aspect that needs to be thought about for data management is what's the hierarchy? How are we going to organize this information? So you could see one example is by by type of function. So we have structural, mechanical, electrical. The other way of looking at it is more like a location. We're looking at tank 1, and then we look at all of those features underneath. And that's how we opted to do it for our client, after discussions with them. I think the other question that comes out of this is when we define what assets are we looking at, say we were primarily focused on mechanical, the question becomes, well, at what level is an item an asset? So for example, a pump you have the pump, you have the motor, you have the connections, it's mounted on a pedestal. So there's a lot of different parts. And at what level do you go down to and say, this is the asset, this is what we want to track? And there's a continuum and there's no exact answer. I think, the general, when you look in the field, the consensus is to to follow it as a maintainable unit. So, for us, it was the pump and the motor. You wouldn't be looking at a bearing or a connecting rod, say, or a impeller as an asset. They're more part of the main unit. So at this point, we've defined our assets. We know what they are. We know how deep we want to go. We've organized them. The question becomes, how do we collect and maintain? And there's a variety of ways. You notice CCTV, that kind of speaks to the work we do with collection systems, assessing pipes and manholes. CMMS, that's computerized management and maintenance systems, will pull data, working with our clients to pull data out of that and evaluate it. Of course, we use ArcGIS, LiDAR, and we are trying to get more into artificial intelligence and machine learning. Not part of what we're going to talk about today, though. So first step was collection of the data. Working with our client, we obtained a list of the equipment of interest, the assets of interest, based on as-builts, based on their data for operation and maintenance. So we had that, we had drawings, and then we were able to go out to the treatment plants. And to assist in this, we developed a portable inspection app that was useful on tablets, iPhones, in which the data for each facility, each asset could then be put in as the inspectors went through the treatment plant. So they had drawings, they would check what pump they were on, for example, note the serial number, note the pump number, its name, its equipment number, and then begin putting in data on the fly as far as what what condition the item is in. And we'll get to that. I thought one of the things that was nice about what we did was, of course, we included photographs. So photographs were taken from, each elevation, north, south, west, east, and then some detailed photographs, nameplate photographs. As you know, all equipment won't always be in operation at a plant. So we also had the ability to record the sounds of the equipment while we were inspecting if it was in operation. So these are examples of some of the photographs we took. See nameplate. I don't know which view this is, but this is a bar screen. Again, motor information for each facility, asset, I should say. And again, example, this gear drive, motor and drive on a clarifier. So all of that went into developing the condition. And, it's a little beyond what we could do today, but inside the app, there were sections for each type of analysis where we talked about noise, corrosion, the mounting, general appearance, evidence of leakage, evidence of past rehabilitation. And then each of these had a drop down for condition, severity ranging from 1 to 10. And that number that was scored then went up into the cloud and went through a scoring algorithm with weights to put out a score for condition. And we also evaluated maintenance data, and I'll show you that in a moment. So for the 5 critical questions, this is question 3. Which assets are critical? We want to understand how the equipment can fail, how often, and a very much probability of failure and consequences of failure, because that's going to figure into our risk management and our maintenance strategy. I want to just touch on the scoring, how we looked at this. As I said, the visual condition assessment was what came back from the inspectors, and the range was 0 to 3.5, 3.5 being the worst condition. Now, the operation and maintenance score was a score that was based on operation and maintenance data that was provided to us. So we had the frequency of repair, the type of repair, observations, costs that were spent over the years on each piece of equipment. And then using those items, we rated them, we scored them. So an example might be, um, we tried to have a metric where if a piece of equipment was, say, was being repaired more than once a month, that got a high score. If its cost of repair was above a level that we considered excessive, however that might be defined, that started to get a high score. And then all of that was pulled together. And then when combined with the condition assessment score, gave an overall consolidated condition score. And I'll get into how some of the more exact scoring in a bit. Criticality was, we took criticality to really be reflective of redundancy. The higher score representing a piece of equipment that had less redundancy, lower with more redundancy. Remaining equipment life, 5 being the least remaining life, 1 being new to very good. And then these two here, consequence of failure and probability of failure, scoring from 1, least consequence, 10 the most, probability of failure, 1 to 100%. This is kind of a broad brush how we worked on the scoring. All of the equipment was scored, and we developed risk scores and business risk exposure scores. And the risk score is a dimensionless number, as they both are. It's consequence of failure multiplied by probability of failure. And then business risk score exposure is the condition score multiplied by remaining useful life, criticality, and then the risk score. So the scores are used a little differently, and we'll see that. Our scales resulted in a maximum business risk exposure score of 2,500. Now this is really getting to the heart of the analysis. When you think about it, when you look at those calculations, you could imagine you could have two pieces of equipment with the same business risk exposure score, but the component numbers making up that score could be very different. So we might have a high business risk exposure, and yet overall it really might not have a high risk exposure, and it's not a piece of equipment or an asset really worthy of attention. So classically in the analysis, the way this is thought of is the probability of failure and the consequence of failure values for each of the pieces of equipment or assets are plotted on this type of graph. Now, when you look at it, we've outlined zones of risk, very high, high, medium, and low. And you see very high is a high probability of failure and a high consequence of failure. And the question you might ask is, well, how has this even come to? And it really is, there's no right answer. It's really more based on an organization's risk tolerance and their own experience. You could imagine, if you would, a very risk averse organization might set parameters where very high takes up most of the graph. So it's really a judgment call on the part of your organization. So continuing, consequence of failure. And these are how we did the rankings, 1 through 10. And we looked at different items: fiscal, public health, regulatory compliance, process of reliability, and public relations. And it's qualitative, and I think it allows for flexibility in how you might look at this. Look at this. The other thing we looked at, the risk zones. It's one thing to assign the risk zone. The next question is, what does it mean? What gets done? And again, that's something that's for each organization to decide. These are our suggested uh, next steps, based on the risk zone. So again, this is something that needs to be looked at, with an owner and a consultant and some type of consensus reached. So this is an example of how we came out with our inspection of the treatment plant, and you'll see very few over in the high area, very high. We have some in the high area, and then more in the medium. And a lot of the data, there's so much data that it all kind of lays on top of each other. But we could do a further analysis when we go back to the tabular data. So when we look at this, this is about where we landed. And when you look at high and very high, it was about 5% of the 5+% of the assets in the facilities. Much of the facility was in the medium area. So this is our second item. I wonder, if you and your facilities, if you have a feeling of where your facilities are, your assets. Kind of interesting. And I know as you're filling out, I guess one of the rules of thumb you always hear, it seems to apply in so many places, that 80-20 rule. 80% of the problem is being caused by 20% of the assets. And it's interesting, we find that in our pipe inspections, it's not quite that. It seems more like 40% of the pipes are causing 80% of the problems. In any case, we're getting some results, and very high is looking like about 27% believe they're greater than 10%. About 9% indicate 5 to 10% and very high, and 58% are showing not known. So I think this is a difficult thing to know if you haven't gone through the exercise. So this makes sense to me. So let's go on. One of the things we did, and I think this is useful, for working together, is to have adjustable inputs. And we have allowed in the algorithms for these different factors to be adjustable. And one of the things is to allow for input from various stakeholders and to understand the sensitivity of the model. How robust is it? And our goal is not to be to have it too sensitive. So final item, I think we're getting to the end. At the end of my time, I just want to mention a couple of things. Theory meets reality. This is, in a way, our lessons learned. Um, I would say, I won't read it, but I would say it's important to be very careful with data management and also be prepared for various scoring scenarios. Sometimes it's missing, bad, or incorrect data. We have to work around that, and also to be flexible. We found, and we learned from our client, the idea, let's field test it. We don't want to get caught up in theoretical discussions. A lot of this is about scoring and weighting. So sometimes it's best to go out and do some real field testing of the scoring. So this just summarizes the journey. And with that, I'd be happy to take any questions. I appreciate your attention, and why don't we open it up for questions?
Thank you, Mike. At this point, we are going to open up for Q&A. Just send your questions through the chat box. As we wait a couple minutes for questions to come in, I do want to thank you again for sharing your time with us today, and thank you, Mike, for sharing your expertise with us. As a reminder, a recording will be available on our website at bartlettwest.com. Mike's contact information is provided here on the slide, and we certainly encourage you to connect with him. It looks like we have a couple of folks that are typing questions, so we will wait for those to come in here just a couple minutes. Thank you, Bob. Sending a note here. Thanks for the presentation. Again, we'll wait just another moment or so. It looks like there is a question why BRE definition includes other factors in addition to the risk scores. Mike, if you would answer that for us.
Okay. The way we did this was um, the consequences of failure and probability of failure combine into a risk score, and then we like to plot them. The business risk exposure score is to take into account more factors to get a more refined score. So when we look back, business risk is going to include issues of reliability, um, criticality, and did I say reliability? I meant remaining useful life, criticality in terms of redundancy, and those other factors so that we can get a little more definition in the score. Okay. Hello, Buster. Good question. Happy that you were able to attend. What are some ways to convince decision makers to invest in a thorough process? I think, when I think about this, we kind of look at, there's always discussion about big data and parsing big data. And I think as people, I think many people are more sophisticated and look to have a more data-driven and rigorous process. When I think about clients we work with, and again, I'm thinking about the wastewater plant because that's so much of my experience. Uh, the job is that's getting done is excellent. The plants are in compliance. Everything is in excellent shape. It runs very, very well. The thing is, it's not the process of managing the equipment is not so rigorous that it could be handed off to someone else. And this is something a lot of people talk about. There's institutional knowledge that it's very hard to pass on, and so I think about that. I do think, decision makers and elected officials really are looking for more a data-driven, repeatable process that that is, to some extent transparent and tells the story. I feel, when we look at this and we present it, I think about the work we've done for collection systems. It really speaks to people. When you see a map and you see all of the pipes mapped with ratings, and the same thing with the plant. When you see all of this equipment, it's not just someone's off the cuff, gut answer, I suppose. So it's an educational process. I think there's a lot to this. And, I think it's really an educational process, and you have to have the right people, who believe in data and, having that data-driven process. I hope that answers.
Okay, I'm not seeing any further questions. So again, if you do have a question that you weren't able to answer, today, feel free to connect with Mike directly. At this point, I'm going to go on and wrap up our webinar today. Have a great day, and we look forward to seeing you again soon. Thanks again for joining us, and thank you, Mike.
Thanks, everybody.